Hello, I'm Avi Stein, and I'm presenting news article text classification and summary for author and topic. And this work would not have been possible without my colleagues, my advisor, Dr. Spiros Mancortis, as well as my colleagues at NYU, Janith and Rachel. So I want to thank them. Okay. So as an introduction, we explored the applicability of natural language processing tasks to a new data set that has some unique advantages. We compared authorship and topic classification in parallel environments. We used information extraction via summarization, and we compared different machine learning techniques for these tasks. So this is all part of NLP, and NLP is used to analyze news, social media, millions of websites, as well as extract data for tasks such as search, which is used billions of times per day. The thing is that human language is messy and complex, and NLP is used to create efficient systems that have less bias, though bias can still be a problem with these things, and it gives us a helpful, clear answer to messy questions. Even if it might not be the only answer, it gives us at least a clear answer, so that has some big advantages. So our goals and why. So we wanted to see how well these approaches can be used in a new setting, such as the Vox Media 2017 dataset. We wanted to leverage the fact that this data had both authorship and topic labels, which allows us to compare them directly. And we wanted to see how information reduction / extraction affects each task, and determine which techniques are the most efficient, like which ML techniques. So authorship attribution, the idea here is that given a group of texts from different authors, you train on that data, and you given a new text, you try to attribute who is most likely to write that thing. So applications range from social media posts, such as on Twitter and Reddit, Facebook, etc., to scholarly articles and works of literature. And usually attribution is done in a forensic scenario and also has some certain privacy implications. Other authorship related attributes that have been explored in literature so far have been things such as like the mood or gender of an author, as well as things like whether or not they are likely to have like a mental disorder. So there's a lot that you can extract about an author from what they write. So this is an interesting task, and it also has a lot of similarities to topic classification. Topic classification is used when you have a bunch of documents about different things, and you want to see how well you can distinguish between those things. And this is useful for automatically annotating documents. And as I said, it's applicable in similar domains as authorship. So that's why we wanted to explore them side by side, because that hasn't really been done. There's a lot of work on them separately, but this provides a good opportunity to compare them directly. And then the last NLP task that we examined was summarization. And text summarization is a form of information extraction and reduction. And it's very natural for humans, for us to do. We naturally summarize things. It's kind of similar to us paraphrasing things. And summaries basically have two main types. There's an informative and there's an indicative. And the informative tries to capture all the information and tells you kind of the story from beginning to end. And indicative is something to kind of get you interested. And there are two approaches to generating summaries. There's an extractive and abstractive way of forming them. And we used extractive here. Abstractive is a little bit more complex. It involves generating new sentence structures, for example. And so about the data, so to go over the information that we're working with, we used the Vox dataset. And Vox is a news source that typically skews a little bit over to the left and is generally a complex analysis or a mix of facts and reporting according to a common media bias chart. And if you can't see it here, I mean, you can Google it, but Vox is right about here. I assume you can see my cursor. And you can see it's kind of in the same region as CNN. It's not quite as cut and dry as, say, the weather. And for example, on the other side, maybe you have Wall Street Journal over here. But generally speaking, it tends to be a reliable news source. And in terms of the distribution of the data, most authors and topics have fewer than 50 articles apiece. But authors and topics with more than 50 articles apiece account for over 90% of the data, which is good. So for example, with authors with more than 50 articles account for 90.8% of the data, and topics with more than 50 articles account for 92.9, so approximately 93% of the data. All right, so data fields that we used from this data set, we used the author and topics for their labels, then obviously the document for the full article text, and we also had a blurb, which is like a one-sentence indicative summary. All right, so data and pre-processing, we had this full corpora of data, and we created 4 main data sets out of it. So we created, for both topic and author, we created a dense and a sparse data set. The dense had, for example, with author, the dense data set had 10 authors, and each author had 100 articles. And for the sparse data set, we included 50 authors, each with only 50 articles. So the goal here was to get kind of a range of experimental results to give us an idea of how well it would work in different scenarios. And the features that we used when we were going through the text, we looked at frequency and term frequency versus document frequency, word count, word engrams, part of speech tags. And we ended up only using the word frequency and bigrams. We ended up not using the TF-IDF or the part of speech. And then we also only included words that we did not include words that were in more than 99% of the documents or in less than 1%. So after doing the feature extraction, we had about 14,000 features. And then we used naive Bayes, decision trees, random forests, support vector classifier, and a multi-layer perceptron neural network with 100 nodes and 20 layers, as well as using the one versus all neural network strategy, or one versus all strategy with neural network. Okay, so initial experiments and results. I'm going to talk about authorship results, then topic, and then both when we used it with the generated topic summaries versus the blurbs. So for authorship classification, on the dense, we're able to get 86% accuracy, and on sparse, we're able to get 70% accuracy with the neural network one versus all. And as you can see, for the other different classifiers, for the dense, they all do fairly well. And then for sparse, there's a little bit more drop off, for example, in the decision tree and the support vector classifier. But generally, they all operate within a certain range of similarity. But the neural network one versus all did the best. And similarly, on topic classification, neural network one versus all strategy did the best here as well. And with the dense data set, it was able to get 74% accuracy and 62% accuracy for the sparse. And again, we kind of see a similar range of results for the other classification methods as well. All right, so then to generate summaries, we wanted to do the same thing on the summaries of each of these data sets. So we find the word importance by finding the word frequency in each of the documents, and then create a sentence importance, which is the sum of the word importance divided by the length of the sentence. And then by doing this, we're able to remove about between 70 and 90% of the original text. So our goal was we wanted to remove about 80% or leave only about 20%. And as you can see, the blurbs for each of these did significantly worse than our generated summary. And on the summaries, there was a loss of about 25% for authorship classification and a loss of about 20% from topic classification. So topic classification is a little bit more robust to this kind of classification. So we thought that was interesting, but we also wanted to go a little bit further. So we looked at some unsupervised analysis of the data, and then we tried adjusting for topic overlap. And we also wanted to examine some authorship edge cases to avoid topic author conflation. So this is from a related work. The only other work that I could find that looked at this data, and they used completely unsupervised, and they were looking at clustering the documents, a different number of clusters. So as you can see from this, there are certain clusters that appear, but they're not really that well aligned with what Vox had actually assigned as their topic. But you can see that there are certain things like political topics that come up, as well as like healthcare related ones, social justice, etc. So what we wanted to do was account for the topic overlap, because what we saw was that there were a lot of topics that were very closely related. So we actually tried two different strategies here. We used the hierarchical groupings of topics. So we created 5 topics from several subtopics. And as you can see here, the subtopics, for example, you have politics and policy is one. And then you have politics, which is a different one. Then you have a lot of different political people, and then other kind of like catch-all mischief of factions. And you can see that these topics are very closely related. Let's see. For example, we put Obamacare and health, even though that has certain political tones. So it's definitely an imprecise science here, but using this method, we were able to get up to 83% accuracy. And then we also, with the manually combined ones, and then we also used a kind of a more loose method to deal with topic overlap, which is top 5 accuracy, meaning that if we took the top 5 most likely topics, and as long as one of those top 5 was, as long as one of the top 5 was the correct one, then we considered it correct, and we got 87% accuracy there. And then we also wanted to look to see if there were maybe some authorship edge cases. So what we did here was we did an intra-topic data set and an intra-topic data set. So intra-topic, meaning that all the articles from the authors all came from the same topic. So as you can see to the right, we considered 3 of the biggest topics in Vox, which were the latest, Donald Trump, politics and policy. And in each of these, in the latest, for example, there were 8 authors that had contributed at least 300 articles. And for this, we were able to get 92% accuracy. And then maybe on a more specific topic, such as Donald Trump, the number of authors, we had like 9 authors that had contributed at least 60 topics, and that was only able to get 64. And that's probably because it was a lot more specific. But, you know, maybe a more general one, such as politics and policy, with 10 authors that had 60 articles, was able to get 81% accuracy. And then we also did intra-topic, meaning that for each author, we only considered 1 article from each topic. So even if they contributed mostly to one topic, we'd only take 1 from each of the topics that they contributed to. And using this, there were 8 authors that contributed to at least 50 topics. And this was able to get 86 or 68% accuracy. All right, so discussion. So there might be authors that focus more on a single topic, and this makes the signal conflated between the two. This raises questions about how maybe we could create better topics for analyzing our news, understanding our news. Also raises questions about how we can disentangle the content and style going on here. We did our best to address these. Things that we didn't particularly address per se was like things that have multiple topics or multiple authors in an article. And we were also curious as to whether or not this could be used for topic or author segmentation. And some of the limitations here are that the article came exclusively from Vox. We did mostly shallow learning. All the text was English, so maybe it's different in different languages. And we noted that topic overlap leads to some ambiguity, so there might be problems there. So future work could entail using other kinds of deep learning techniques, such as recurrent neural networks or long short-term neural networks. Maybe our previous speaker has thoughts on that. The effects of language, different types of languages or different languages. We could use maybe an abstractive summary technique to get better accuracies when we're doing summarization. Though those usually will take longer to generate. As well as the effects of multiple translations on style. That, for example, if you take a text, translate it into one text and then translate it back, what effects does that have on authorship or on topic classification? And maybe you could use this effect to do adversarial models, who knows? So our conclusion is that authorship and topic classification perform similarly on both dense and sparse data sets. Topic classification is more robust to summarization.